Okay, this is a video to help you understand how to use my vector template. The example I'm going to use is problem 11 from chapter 3 of Giancoli, which I've written out by hand here, and I've put in a photocopy of the figure that's referred to in the question. What I'm asked to do is to determine the sum of these three vectors. That is, I've got to add these three vectors together, and to give the resultant in terms of components, magnitude and angle with respect to the positive x-axis. The positive x-axis being that one there. Now the first thing that I always do when doing something like this is to draw my own vector diagram, because it makes it easier for me to understand what I'm doing. So this is vector C, and it has a magnitude of 46.8 arbitrary units. This is vector A, and I'm drawing the approximate lengths here, and it has a magnitude of 66 units, and it has an angle of 28 degrees to the plus x-axis. This is vector B. I drew it a little bit long there. It has a magnitude of 40 and an angle of 56 degrees to the negative x-axis. Alright, so to start off, what I do is I've got my vector names here, A, B and C. I've got a space for their magnitude and a space for their angle. So what I'm going to do is now enter those in here. So A has a magnitude of 66 degrees and an angle of 28 degrees. B has a magnitude of 40 degrees and an angle of 56 degrees. And C has a magnitude of 46.8 and is directly down, which is a minus 90 degree angle from the positive x-axis. Okay, once I've entered these in, I need to determine both the x and y components of each of these vectors. If I look at these, the components are going to be given by the projection onto these axes. So that's the y component, and that's the x component of A. So you can see here I have a right triangle, and in here the angle is 28 degrees. If I do the same thing with vector B, and again I'm looking at the angle with respect to the x-axis, but this time the minus x-axis, I've got these components here. So what I try to do when I'm doing this is always to try to find the angle with respect to the x-axis, because when I do that, when I'm figuring out my trigonometric functions, they're always the same. I can see that this, which is the opposite, and this is the hypotenuse, so that means that my y component will always be the sine. So it's going to be whatever vector it is, let's say A, sine theta, and this one here, the x component, is the adjacent, so that's always going to be A cosine theta, where A is the magnitude of whichever vector I'm talking about. So if I want to find out now what the x component is, I just have to do 66 times the cosine of 28 degrees, which is 58.27. 58.27, and then I have to do 66 times the sine of 28 degrees, which is 30.99. Now I'm going to go over to B, and I'm going to determine what its components are. Remember, the components are always at right angles to one another, so that we can arithmetically add once we're done. So we want 40 times the cosine of 56 degrees, 22.37, thank you. And we want 40 times the sine of 56 degrees, which is 33.16. Now, in this final case, we see that C runs along the negative y-axis. So that means there is zero component of that vector in the x direction. So I put a 0 in there, and that means all of it is in the negative y direction. I'm going to put 46.8. Now comes a very important step. I now need to make sure my signs, S-I-G-N, are correct. If I look at C, I see that's in the negative direction, so this becomes a negative. Let me go back to A. A is in the first quadrant, so both the x and the y components must be positive. In the second quadrant, the x component is negative and the y component is positive. In the third quadrant, both components are negative, and in the fourth quadrant, the y component is the x component is positive and the y component is negative. So I do this little thing going around here, and then I go in and put the correct signs in for each one of them. So B, we have a negative x and a positive y, and A is positive in both. Now, to determine what my resultant should be, all I need to do is arithmetically add the individual x and y components of all three. So I need to add 58.27 to minus 22.37. Yeah, that's correct, which is 35.9. And then I need to add 30.99 to 33.16 and subtract 46.8, which gives me 17.35. Now I can do a quick check here and see if that makes sense. First of all, I can look at the y components of B and A and see how big they are. And I see that if they're about this big and this one comes up here, it adds to it, it is actually bigger than what is in the C direction. So my component in the y direction should be slightly positive. Now if I look at my component in the x direction, it says 35, which is significantly less than this, so maybe it's around about there. So I'm looking at a resultant that's somewhere in here. Does that look right? Yeah, that looks about right. So the angle I'm going to end up with should be about half of 28, maybe 14 degrees. So all I'm doing is a double check here to make sure that I'm on the right track. So let's see how I would go about finding that angle. Well, for me, the easiest way to do is to use tangent. Let me just redraw this little triangle out here. And again, if I'm always being consistent about going from with respect to the x-axis, I've got a theta in here. I've got 35.9 here and a 17.35 here, and this is a right angle. So I'm going to use tangent, which of course is opposite over adjacent. And I'm going to say tan theta equals 17.35 divided by 35.9, or theta is equal to the inverse tangent, 10 to the minus 1, of 17.35 over 35.9. Make sure your calculator is calculating in degrees for this particular problem, not radians. And the inverse tangent of that is 25 point, well, it is less than A, but it's 25. Is that correct? 17.35 over 35.9. Yes, that's it. So it is in the right ballpark. So I was just estimating quickly wrong. So that's 25.8 degrees. And now, in order to get R, right, R is going to be this length here of this triangle. This is the magnitude of R. So I can get that with the Pythagorean theorem, which means that I'll square this and add it to the square of this and take the square root, which is 39.87, which looks about right, 39.87. Okay, now that shows you a simple way to use it. If you're given other problems where you might want to find different things, like this one here, this is problem 15 in Giancoli. What it's looking for is C minus A minus B. Now with the vector template, you'll see that there are three possible things. So what I can do now is I'm looking for plus C, minus B, and minus A. And since I've already done the work over here, I'm just going to transfer it in. So minus A is going to be minus 58.27, minus 30.99. Minus B is going to be minus times a minus is a plus, 22.37, minus 33.16. And then my final one is C, which is 0 and minus 46.8. It doesn't change sign because it's positive. Okay. Notice I didn't have to do any of this because I had already figured out all of these over here, and now all I'm doing is taking the negative of those vectors, and now I'm going to add all of them up. So in the x component region, I have negative 35.9, which is correct. And then this one is a really very negative. Minus 110.3. Okay, now I'm going to go up here and double check. So my y component is minus 100. My x component is minus 30. And so I'm going to try to draw in an approximate resultant here when I add all three together. And it gives me this. So now I'm going to be calculating this angle here. Remember, I try to be consistent about taking it always from with respect to the x-axis. And I'll have to be careful about what it asks me in the problem to define the angle with respect to. If it's with respect to the positive x-axis, I could go this way, add 180 degrees to that angle, or I could go this way, subtracting this angle from 180 degrees and giving a negative angle as the answer. So this, to get the angle, is going to be tan to the minus 1 of negative 110.3 over 35.9, which is going to be just 110.3 over 35.9. which is 71.97 degrees. And I just go up here and double check, and I say, yep, that looks like about 71 degrees. And now I'm going to do, again, put the Pythagorean theorem to find the magnitude of the resultant here, which is 115.995, which gives me a 116.0. And that looks about right as well, since this is minus 110. This one is 116 degrees with an angle of 71.97 south of or towards the minus y-axis. So if I'm going to write down this as an answer,